What you are seeing now is engineering that could quietly reset the entire auto industry. This Tesla's carbon-wrapped motor is coming to the 2026 Model 2, and these implications are actually bigger than anyone expected. Before we get into it, make sure to subscribe to our channel for more Tesla innovative technology breakdowns. The moment the industry didn't see coming. Car manufacturers believed for years that there was a hard ceiling on electric motor performance. Not because batteries were not good enough, but actually because physics said so. Spin an electric motor too fast, and the rotor will literally try to tear itself apart. Metal will stretch and heat build up, which makes the efficiency collapse. With all this happening, failure becomes inevitable. This ceiling hovered around 16,000 RPM for several decades. Everyone accepted it so far, but not Tesla. When Tesla first revealed a carbon-wrapped rotor in the Model S Plaid, most competitors ignored it as overkill because it was an expensive trick for a six-figure performance sedan. It was considered something flashy, impressive, but irrelevant to mass-market vehicles. This assumption is exactly what's shocking the industry. Tesla is now preparing to bring a new generation carbon-wrapped motor, which is stronger, lighter, and also cheaper. This motor will be used in its most important vehicles, like the 2026 Model 2, which is a car expected to redefine the term affordable EV. This time, it's not just about speed. Why electric motors always hit a wall. To better understand why Tesla's new motor matters, first, you need to understand why electric motors fail in the first place. Inside every electric motor is a rotor that spins at incredible speed. Centrifugal force pulls outward on the rotor with massive pressure as the RPM increases. Traditional steel rotors can only handle so much pressure before they start to deform, vibrate, or crack. Heat makes this problem worse because the metal expands, tolerance tightens, and overall efficiency drops. That is the reason why most EV motors are tuned conservatively, where manufacturers sacrifice torque and speed to preserve reliability. They have to add weight, cooling, and accept losses to prevent deformations or cracks. But Tesla chose a different path here. Instead of making the rotor thicker or heavier, Tesla wrapped it. Carbon wrapping, the breakthrough that changed everything. The original Tesla carbon-wrapped motor now uses a thin carbon fiber sleeve, which is less than a millimeter thick, and it is wound around the rotor at extreme tension. Carbon fiber does not behave like metal, so it would not stretch under centrifugal force, and this will resist deformation. Its tensile strength is multiple times higher than steel, so as a result, the rotor could spin past 20,000 RPM without falling apart. This single innovation unlocked several possibilities, like faster acceleration, higher sustained power, and better efficiency, because the smaller, lighter motor could now do more work while consuming less energy. But Tesla didn't just reuse this design for the Model 2, they evolved it. A motor borrowing from aerospace, not automobiles. Tesla is reportedly moving beyond conventional carbon fiber into a carbon-graphene hybrid composite for the upcoming model. This is a material approach that is inspired by aerospace and high-performance energy systems. Graphene, when measured at the atomic scale, adds extraordinary tensile strength and thermal conductivity without adding much mass. And when it is bonded into a composite sleeve, it could change how heat and stress move through the rotor. Instead of having hotspots forming under extreme loads, the heat will spread rapidly across the surface and dissipate before it even becomes a problem. This would mean less cooling demand, lower electrical losses, and way more consistent performance over time. In other words, the motor stays cooler for a longer duration while spinning faster than anything in its class. Why faster RPM means better efficiency, not worse. Now, this is a point where many people get confused. Higher RPM sounds inefficient because more speed usually means more energy loss. But that is not the case here, because electric motors operate most efficiently when they can maintain power without increasing torque demand. So by spinning faster, Tesla's motor can deliver the same output while using less current. And lower current means lower resistive losses. Lower losses would mean less wasted heat, and that is why the Model 2's motor does not just promise better performance, but it also promises less energy consumption per mile. In real-world terms, this innovation could mean driving at highway speed while using significantly less power than current compact EVs available in the market. It would also provide much stronger acceleration. A smaller motor doing a bigger job. Another silent benefit of this carbon wrap design is that it downsizes. Tesla would no longer need a bulky motor to hit performance targets because the rotor can now handle higher stress. The Model 2 motor is expected to be lighter than previous performance motors despite its potential to deliver comparable or better output. Less motor weight would also mean better weight distribution, improved handling, lower rolling and initial losses, along with reduced strain on suspension and brakes. All of these things would fit directly into the efficiency and longevity of the motor and car. This is how Tesla squeezes high-end engineering into a low-cost platform without compromising on anything. The rare earth problem no one wants to talk about. Most modern EV motors rely on rare earth magnets like neodymium and dysprosium, which are powerful in their performance, but they also come with serious problems. They are quite expensive, environmentally destructive to mine, and nearly the entire worldwide supply chain depends on a single region. This is an enormous risk for a company that is planning to build millions of cars each year. Tesla understood this bottleneck years ago, so instead of doubling down on rare earths, Tesla chose to redesign the motor architecture itself. It is using alternative magnet strategies that are combined with ultra-high-speed operation to compensate for lower magnetic density. The carbon-wrapped motor is the breakthrough that makes this possible. By spinning faster and staying stable at high RPM, Tesla can now achieve high power output without relying on exotic materials. This decision alone is enough to reshape the entire economics of EV manufacturing. How the Model 2 motor gets so cheap. Here is the point where things start to sound unbelievable because, despite using advanced composite materials, Tesla's Model 2 motor is still expected to cost under $1,000 per unit at scale. Now you might be wondering how this is going to be possible. The first reason is the material efficiency, because the carbon sleeve is extremely thin and the amount of composite used in it is surprisingly small relative to the performance gain. Secondly, it is possible because of recycled inputs, where Tesla is increasingly using reclaimed carbon fiber from aerospace waste and end-of-life components. This dramatically reduces the cost of raw material. The third reason is the automation, as Tesla's rotor winding process is almost entirely robotic, which is controlled by air systems that maintain precise tension and alignment with near-zero defect rates. The fourth cause is the vertical integration, where Tesla does not buy motors but builds them itself. This eliminates supplier margins, logistics overhead, and redesign compromises. The cost math flips entirely when you combine all of these. A motor that once seemed too advanced for mass production is now becoming cheaper than conventional designs. Why competitors can't copy this quickly? Carbon wrapping sounds quite simple on paper, but it is brutally difficult to execute in reality, especially at a massive scale. The tolerances are extreme, while the winding tension must be exact, and any flaw could become catastrophic at 25,000 RPM. Legacy automakers rely heavily on suppliers who are not really set up for this kind of manufacturing, and retooling entire production lines would take years and billions of dollars. Tesla has already managed to do the hard part, and by the time competitors react, Tesla's second-generation system will already be shipped in millions of vehicles. That is the real shock for the entire automotive industry. Durability that makes gas engines obsolete. Now let's talk about the lifespan of these vehicles. A typical gas engine lasts around 200,000 miles if it is well maintained. It contains hundreds of moving parts and all wear out at different rates. A conventional EV motor improves in this aspect, but it still suffers from heat stress, bearing wear, and magnetic degradation. Tesla's carbon-wrapped motor will change the equation entirely because with fewer moving parts, minimal vibration, and dramatically reduced thermal cycling, the motor's projected lifespan will expand into seven-figure mileage territory. For Model 2 owners, this means the motor may never need replacement during the car's usable life, and the maintenance would drop to almost nothing. What this means for real owners. For real owners, this means lower maintenance costs, fewer breakdowns, and longer vehicle life, along with higher resale value. These savings will dramatically increase over the next decade. The comparison here is not just with gas cars, but also with the other EVs on the market. This is why Tesla is not just building a cheap EV. They are actually building a low-cost ownership machine. The bigger picture. Why this terrifies the industry. The carbon-wrapped motor not only makes the model more affordable or cheaper, but it also makes it scalable by removing supply chain risk, slashing manufacturing cost, reducing environmental impact, and increasing reliability at the same time. This combination is devastating for all the competitors who are still juggling with trade-offs, because if one car can be cleaner, faster, cheaper, and longer lasting at the same time, then what is left there to compete on? The hidden efficiency advantage. There is another benefit that only a few people talk about, and that is battery preservation. Because now the motor can run cooler and more efficiently, it will place less stress on the battery pack over time. Lower heat means slower degradation, and slower degradation means usable range stays higher for longer durations. This could extend the battery's effective life by 7 years without changing the core chemistry at all. Again, this is not flashy, but it is completely transformative. Why this motor fits the Model 2 perfectly? The Model 2 is not meant to be a luxury car. It is actually meant to be everywhere. When a motor can thrive under constant use while resisting wear and sipping energy instead of consuming heavily, then the mission of Tesla would become successful. And Tesla is going to take the first major revolutionary step in the direction of making this vision a reality, where you will see cities filled with Teslas, long commutes in EVs, and less frequent maintenance. Tesla didn't downscale its premium product to make it available for everyone, but they actually optimized their manufacturing and removed the bottlenecks entirely. Anyone can build a fast car with precise engineering, but what Tesla is doing here is far more dangerous for its competitors. They are turning advanced engineering into a cost-cutting tool where they will be able to make high performance the cheapest option instead of the most expensive one. And they are aiming to do it at a scale that no one else is ready for. Tesla's carbon-wrapped motor is not just an upgrade, it is actually a warning to all the other automakers in the market. The rules of efficiency, cost, and durability are going to be rewritten, and they will start with the Model 2. If you enjoyed watching this breakdown video, then do subscribe to our channel for more deep dives into Tesla manufacturing processes and factories.